So I've started recording for people who will want to review the video later. So the symbol for integration is that one. That is the symbol for integration. And I gave you some notes, you can be able to go through them. Then we have a dx here. So this one, the dx signifies that we are integrating in terms of x. So those are the two symbols. So the dx signifies we are integrating in terms of x. If I have this one, dy, it means that I'm integrating in terms of y. So you can be able to have that. So that is the symbol basically of integration. So the symbol of integration, it is as simple as that. So you can be able to see that what signifies. So from there, I can be able to go to, first of all, power rule of integration. Power rule. If you have number one, the power rule states that when you have the integration of x raised to power n, dx integrating in terms of what we normally do, we add 1 to the power, and then we divide by the new power, and then plus a constant of integration. So the constant of integration basically is found when you have boundary conditions. When you have boundary conditions, we shall be able to come and calculate the constant of integration. I'm just calling it C. Most books will call it C, can be called K, but most books they call it C. So after you have integrated, you must add a constant of integration C. So add 1 to the power, and then we divide by the new power. Only that. Add 1 to the power, and then you divide by the new power. Let's do an example to demonstrate this. Example 1. Let's integrate x squared dx. So this one is very simple. This one is very simple solution. So I'll add 1 to the power, and then I divide by the new power, and then plus a constant of integration. So I'll have x to the power 3 all over 3 plus a constant of integration. We have said our C is a constant of integration. So we just add 1 to the power and divide by the new power. So number 2. X. You can be able to try that. Tell me what you'll be getting for that one. You can use your mic if you prefer. That one there, x to the power 4 dx. So at least someone has gotten it. So the final answer will be x, you add 1 to the power, and then you divide by the new power plus a constant of integration, and so you get x to the power 5 all over 5 plus c. And do another one, number 3. Integration of 2 x negative 3 dx. Integrate that one there, 2x negative 3 dx. So in integration, the constants do not affect anything. So it shall remain the way it is. Sorry. So the constant, you can either remove the constant outside or you remain the way it is. So I'll make it as simple as possible. So this one, the same as, so I'll deal with the function. So the 2 is still there. You can be able to see the 2 is still there. Then I add 1 to the power, and then I divide by the new power plus a constant of integration. So when you do that one, you'll get it what? You'll get this one as 2x negative 2 all over negative 2 plus c. And in mathematics, there's something we can be able to do. You can be able to cancel that one and that one there. So we shall be able to remain with negative x, negative 2 plus c. So you can be able to cancel the 2 and remain with that one. So you can be able to see when the constant is not playing so much role in that. So let me continue because we shall need all this next week. Number 4. Number 4. The integration of 4x half dx. We try that one. Integration of 4x raised to power half dx. So this one again, what we shall be able to do, we shall just again add 1 to the power x half plus 1 all over half plus 1 plus c. So a half plus 1 is 3 over 2. So 4x 3 over 2 all over 3 over 2 plus c. Now this 3 over 2 can be able to come up, we can be able to divide. So check this one out, 4 divided by 3 over 2, the same as 4 times 2 over 3, the same as 8 over 3. If it comes up, when I'm dividing it, you do the reciprocal. So the final answer will be what? 8 over 3 x 3 over 2 plus c. So you must be able to simplify. You must always simplify to be able to get the desired answer. Anyone with a question so far? We'll do this other one now. Number what? Number 3. Number what? Before I do that one, let me introduce some laws of indices that are very important. We have some laws of indices that are very important. Laws of indices to help us. Only 2 laws. The first one is this one. The nth root, you'll be able to see this one clearly. The nth root of x raised to power a is the same as x a over n. The nth root basically comes to the denominator. Basically comes to the denominator. I'll show an example for that. Number 2, 1 all over x raised to power n is the same as x negative n. So when a positive power will come up, it shall become negative. So these 2 rules are important if you are if you are to evaluate using power rule. And I can be able to give you one. So just remember, the power rule cannot work with what? With a fraction on the denominator. Only works when you have what? A fraction on the numerator. So that's why we are bringing it up. Again, you can't work with the nth root, square roots, third roots, fourth roots. You must be able to use this one. So I'll do an example on that. For example, we integrate 1 all over x raised to power 4 dx. So you can be able to start avoid this one. This one can never work. You can try what you can be able to avoid because these are the mistakes that I see. So avoid answer. You say it is 1 all over x 4 plus 1 all over 4 plus 1 and then plus the constant of integration. So we avoid that. That is wrong. That is wrong. You avoid that. You cannot be able to use power rule when you have a number on the denominator. So I will use what? Laws of indices. So the law of indices says when I have a power down positive, the law of indices, then when you have x over 4, if it comes up, it's the same as x negative 4. Positive power becomes negative, and vice versa is still the same. And if you had a negative power, it could have become positive when you went up. Now, instead of having that, we shall have the integration of x negative 4 dx, which is now easy. That is x negative 4 plus 1 all over negative 4 plus 1 plus c. Again, when you do this one, you shall get x negative 5, no, x negative 3. I'll get x negative 3 all over negative 3 plus. So you can be able to see a law of indice has been able to assist us to be able to do to hack that one out. So again, I will repeat, the parallel only works when you have a numerator, not a denominator. Now the other one is for the nth roots. For the nth root, let me now demonstrate for the nth root. Number 2, when you have the integration of power 3 of x dx. That is the third root of x, the third root of x. So we have said this one, using laws of indices, when you have an nth root, it will come where? On the denominator. So 3 square root of x, the 3 is outside, is the same as x 1 over 3. Because remember, x can be given as power 1. So when you have an nth root, if it was a square root, it could have been a half. Third root, a third. Fourth root, a fourth. Fifth root, 1 over 5. Sixth root, 1 over 6. 100th root, 1 over 100. So usually like that, like that. Let me now do this one now. It becomes simple. X a third, x. I'll have x 1 over 3 plus 1 all over 1 over 3 plus 1 plus c. When you do 1 over 3 plus 1, what do you get? You get 4 over 3 all over 4 over 3 plus c. And after doing that now, you can easily be able now, this one, check this one out. This one can easily be able to come up. I can be able to simplify further. This one can be able to come up, this one, the 4 over 3. So when it comes up, it will be the reciprocal, 3 over 4, x 4 over 3 plus c. Remember 1 divided by 4 over 3 here. They say the same as 1 divided by 4 over 3. So I'm dividing by 4 over 3. The same as 1 times 3 over 4. And that's what I have, 3/4 there. Anyone who needs clarification on those two that I've introduced? So the exercise I've given, Mike, kindly mute, is 3x squared plus 2x plus 1. We said we can be able to integrate each and every term that is there. So the same thing I'll be able to do. So answer here. I'll have the first one is 3. I add 1 to the power, and then I divide by the new power. And then again the 2. I add any number can be given as power 1. So 1 plus 1 can be given as power 1, and then 1 plus 1. Finally, I have 1. So remember 1, maybe I have not mentioned 1 is still the same as x raised to power 0. So I can be able to introduce x to power 0. So x to power 0 plus 1 all over 0 plus 1 plus a constant of integration. So remember 1 can be given as x raised to power 0. Any number raised to power 0 is 1. So here the answer will be what? 3 x to power 3 all over 3 plus 2x squared all over 2 plus x1 all over 1 plus c. Then I can be able to simplify this one. I can be able to cancel. So I remain with x to the power 3 plus x squared plus x plus c. So what are we noting here? That the integration of what? When integrating, number one to note. Number one to note is this one. So note, to the integration of x, the x will always be what? The same as the integration of x raised to power 1. The x, the imaginary one that is there is the same. Yeah, the integration of what? Of the 1 dx, the same as the integration of x raised to power 0 dx, which you should always get it as what? X. This one, when you integrate, will get what? X squared over 2. So from this one, we can be able to take one point out, that if you're integrating the x, it doesn't matter the x, you should be able to get just x. Again, when you're integrating dy, you should be able to get what? Y. To integrate the x, you get x. Integrate dy, why are you doing that? Remember, there's a topic you did not do on, I don't know if you did differentiation on business maths, but integration is the opposite of differentiation. So the integration and the differentiation is as if it is cancelling. So you're remaining with y. So can someone try this one out? Can someone tell me the integration of 2 dx will be given by what? And the integration of negative 3 dy. The answer will be what? The integration of those. The integration of those will be given by what? If you can be able to get that one, then at least you have gotten what? So when they say we solve dy dx, so we are on a separation of variables. I had muted a bit, so I have to repeat. So you differentiate 2 dx, you're getting 2x plus c, negative 3 dy, you're getting negative 3y. Because when you differentiate dy, you get y. So separation of variables, we have ordinary differential equations, ODE, and ODE, we are saying an equation that involves derivatives, only that. So example, we want to solve this equation. So what are we being asked to do? That is the first point. You're told to solve. So what are you supposed to do? So when you're told to solve such an equation, what they are asking you is to find a solution in terms of what? X and y. Now check in my equation. In my equation, I don't have x and y. I have dy and dx. They are different. I'm not multiplying d times x. I'm not multiplying d times y. Remember that dy signifies what? That I've differentiated y. So the d signifies is one quantity. So the x, this one here, this one means what? Is a derivative of x. If I say dy, this one signifies what? Derivative of y. So it is one function, it is one complete, it's not a d times x, it is one function on its own when you read it. So remember, integration is the opposite of what? Differentiation. So integration is the opposite of what? Differentiation. So in the earlier example, I had asked, when you integrate dx, what do you get? And someone try. In the previous example, when you integrate dx, we start from there. What do you get? When you integrate dx, what do you get? Mike?
Get x.
Okay. You get x, okay? Another person? Okay, so now you are seeing it now. We want to solve in terms of x and y. So that's why we're integrating the dx to get x. So when you get x, is a function of x now alone. That's why we want to integrate that function. So you'll get x plus c. X plus c. So let us solve this one now. So this is the equation that I wanted us to solve. We solve this one now. I'm repeating the equation again. dy is equals to dx. So when you are told to solve such an equation, so solution, what we need is to do what? I'll ask a person, what do we need to do? In short, what do we need to do? We want to solve it in terms of x and y. We don't want to have dx and dy. So what are you supposed to do? None. So what are we supposed to do? Mike Jr.?
I think you need to integrate them differently.
Yes, correct. You integrate both sides. Only that. So integrate both sides. Both sides. Only that. Only that. You just integrate both sides. So that's what I'll do quickly. So I'll have dy is equals to the integration of the x. When you integrate dy, I think I had said, when you integrate dy, you get what? Y. When you integrate dx, you get x, and then plus a constant of integration. So now here, we don't add the constant of integration both sides, because when you add the constant of integration both sides, it will cancel out. This is what I mean. We only add the integration on one side, and most books they add the constant of integration on the right hand side. That is the normal norm. So avoid this. Avoid that. When you integrate y, you'll get y plus c, and then here you get x plus c. So you can be able to see when the c will cross over, you will not have a constant of integration. And the constant of integration, I've said, it will be determined by the boundary condition. And I'll show you how to get the constant of integration later. Or I just show you right now what I mean. So when you solve this one, you will get y is equals to x. It will not have any constant. So no constant. You can be able to see no constant. So you avoid that. You only add the constant on the right hand side. Only on the right hand side of the equation. So I'll demonstrate this equation, how to get the value of c. So again, I can be able to rephrase this one in another way. Check this one out. So dy over dx. Sorry, what am I doing? Friends? We solve the same thing. Dy is equals to dx. When x is equals to 2, y is equals to 1. We try to solve for that one. We try to say, no, I've given you, so this one, I'll call it what? Those are now the boundary conditions. Those are the conditions that are there. I was telling you about. So these are the conditions that will be given if you want to calculate the value of what? The value of c. So this one, we did what? We integrated both sides, you remember? dy, and then we integrated here dx. And after integrating, we came up with what? Y. We came up with y is equals to x plus c. We said we just add one c on the right hand side. Now, using the boundary conditions, the conditions that I've given you, we can be able to substitute. So the value of x is equals to 2, and the value of y is equals to 1. So where there's a y, I replace with 1, and where there's an x, I replace with 2 plus c. So this one means that c will be given by what? By negative 1. So now in my equation, instead of having my c, I'll have y is equals to x minus plus, my c is negative 1. So I'll have y is equals to x minus 1. So that is the final equation. So the boundary equation can be able to assist you to get the value of c. So integrate the normal way we have done, but now the conditions comes later after integration. Where there is a y, I've replaced with 1. Where there is an x, I've replaced with 2. Then you solve for c. How have I solved for c? The constant 2 will cross over, will become negative. 1 minus 2, you'll get it as negative 1. Now in my equation, instead of writing c, I write what? Negative 1. you can be able to see. So that's how you do it if you have boundary conditions. That's why I was saying you only add one c on the right hand side. Let me give you another equation you can be able to try to solve. Number 2, we solve for this one. dy dx is equals to 2. dy dx is equals to 2. dy dx is equals to 2. We solve for that one. Dy dx is equals to 2. So now this one is almost the same as what we had, but we need to manipulate this one. So remember, you can integrate. So the first note, I must write the first note. You need to be able to get it very clearly. Note, we can't, very important, we can't integrate when either dy or dx is on the denominator. So very important, you can never integrate. You can never integrate at now integrating both sides. You can never integrate when dy or dx is on the denominator. And you can be able to see the one that I've circled here already is on the denominator. So we can't integrate both sides. So what do we need to do? What do we need to do to bring the dx up? So I repeat my question here. What do we need to do to bring the dx up? I have that one. Can someone try? What do we need to do to bring the dx up? Anyone wants to try? What can I do to bring the dx up? Is a mathematical principle that you learned in high school. I believe you are around their class 6. Mike Junior?
Okay, I think we multiply both sides by dx over 1.
Sawa. Correct. I've seen other people are responding. Can you actually multiply both sides by dx? Oh, yeah. There's someone else who was typing. I was waiting. I'm waiting for them, but they're not. Emmanuel Makelele. I'm waiting for his answer. I had given permission for you to be using your mics as long as if typing, I think typing takes a bit of time. So if you want to do it, if you want to talk, you can be able to give me the answer. So I think they've gotten it. You multiply both sides by dx, or in short, I can use a principle that I learned, cross multiply. Cross multiply, I think, will be able to work. So any number can be given as over 1. So when you cross multiply, you'll get what? dy is equals to 2 dx. Now, all of them are on the numerator. They are on one line. So it is possible not to integrate both sides now. So you can either multiply by dx and then dx to remove it. You'll still get the same thing. Or you just cross multiply. Now integrating both sides. Now I integrate both sides. Now it is easier for me. So when you integrate dy, we said you'll get y. The 2 is a constant, it will not play any part. When you integrate the dx, you said you will get what? X. And then plus a constant of integration. Plus a constant of integration. So can we be able to see the 2 is still remaining? The 2 is still remaining. The 2 is still remaining. The 2, yes, multiply both sides of the equation by dx. Yes, Emmanuel Makelele, that's correct. So I want you to do this one now. You guys are bright. You are getting it quickly. I thought it will take me forever for you to be able to understand this. dy dx is equals to x. That one there. I'm giving you only 3 minutes. You solve that one. dy dx is equals to x. The ones will always be there. So if I do it, first of all, I'll cross multiply this one to come there. So I'll have dy is equals to x dx. Then I'll integrate both sides. I'll integrate dy, is equals to x dx. Integrate both sides. Integrate both sides, dy you get y. Dx you get what? X squared. You add 1 to the power, and then you divide by the new power, and then plus c. So people forgot to divide by 2. I don't know why. You add 1 to the power, and you divide by the new power. I'm not seeing the 2. I'm not seeing the 2. Everyone made that small mistake. You add 1 to the power, and you said you always divide. Please, you always divide. So something we are noting in this example, that for you to be able to come and integrate, the x has to be on the same side with the dx. Why? They are similar. You can be able to see here. Let me show you with the pen. So if you want to integrate, you can be able to see the x has to be the same with the dx. Then on the side of the y, it is alone because there is no y. So when you're integrating such for that, maybe what we are noting is that note that x has to be what? Has to be with dx, and y has to be with what? With y. Very important. If you want to do such, the x has to be with dx, and the y has to be with what? dy. Very important. So there's one more integration I'd forgotten to give you. I'll go back to some integration. Integration, something I'd forgotten and I've remembered. The integration of 1 over x dx. This one, even if I use power rule, it will not work. So the integration of 1 over x dx from the mathematical table is given by ln x plus c. So what is ln x? So ln x, this one is log to base of e of what? X. That is log to base e. What is e? E is a famous function in the calc that is called the, I think you have heard about it, exponential function. Exponential function. So when you integrate 1 over x, please don't use the power rule. It will not work. When you have 1 over x, you'll always get ln x. When you have 1 over x, you'll always get ln x. We can try using the power rule and see if it will be able to work. So we can try something to avoid. Let's see something to avoid. I always love to say something that we can easily be able to avoid. Something that we can easily be able to avoid. I'm not getting what I want. Just creating some pages for me. Those ones will be okay. So I'm here. So we have said that when you integrate 1 over x, you'll get ln x. Let's do something that you can be able to avoid. Because again, people will say you can be able to use power rule. It will not work on this one. Why? So let's do something you can be able to avoid. Remember, if I use, we said on the power rule, 1 over x, we can't integrate 1 over x. We must be able to use some laws of indices. So this one is of power 1. When it comes up, it shall become of what? Negative 1. You always integrate functions on the numerator. So let us now apply the power rule and see. So we shall get the integration of x negative 1 dx. So we shall add 1 to the power. And then we divide by what? We divide by negative 1 plus 1 plus c. So what is negative 1 plus 1? That's the same as what? X raised to power 0 all over 0 plus c. We know that x raised to power 0 is the same as x to the power 0 the same as 1. So you shall be able to get 1 over 0 plus c. Can someone give me 1 over 0? Someone kindly use a calc somewhere and get for me the value of 1 over 0. Get for me the value of 1 over 0. I'm demonstrating why power rule cannot work. Give me the value of 1 over 0. Yes, Junior.
That is math error.
Okay. Another person to confirm. 1 over 0. Even if you have a phone calculator, it will work. It will be able to give you a value. Because it is very, very critical. So 1 over 0. No one is typing. Okay. Then let me go with the answer of Mike. So I've seen one person is trying to type. Or infinite. The calc will say math error. So math error. So this one here, 1 over 0, that one. That one what? We call it undefined. 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 It's not infinity or math error. You cannot be able to divide one with nothing. It is impossible in math. So power rule cannot be able to work. And I've demonstrated. So avoid this. You just remember that when you integrate 1 over x, when you integrate 1 over x, you get what? ln x plus c. You just get ln x. You just have to remember that. You just have to remember that when you integrate 1 over x, you get ln x. So let me go give you another example close to that. You try this one, integrate this one. I think we are at now number 4, if I'm not wrong. dy all over dx is equals to y. That one there. Give me some answers. Give me some answers for that one. Philomena, you are close. The answer. Then you knew. So first of all, I'll cross multiply. Any number can be given as over 1. So we'll get dy is equals to x dx. Sorry, not x, but y. Sorry for that. Y. Y dy. Now we can't integrate y because here these are not similar. These are not had given you earlier here. Check this note out if you are following. No, I've already wrapped, so I don't have the notes. So the note I had given had said you can integrate the y has to be with the side of dy. Dx we don't have anything, so it will remain the way it is. So how can we be able to bring the y on the side of dy? We divide both sides by y. So if you want to bring that y on the side of dy, we can integrate like that. So I'll divide both sides by y to remove this y this side. I want to remove it here, and again I divide this side by y. I bring it that other side. So you remember you can multiply or you can still divide both sides. So that's the first step. So here you remain with dy all over y is equals to what? Dx. We integrate like terms. If there's no like term on that side, you bring it this other side by dividing or multiplying. Now this other one, this one I want you to see it as dy over y. Clearly, this one is the same as 1 over y dy. That one is the same as 1 over y dy. So I'll have 1 over y dy is equals to dx. Now I can be able to integrate both sides because you can be able to see on the side of dx, I don't have any y. On the side of dy now I have a function of y, which is very good. And when you integrate 1 over y, what do you get? ln y. When you integrate dx, what do you get? X plus a constant of integration. And you are done with that one. So the trick was to bring terms together. The trick was just to bring like terms together. That's what I was saying, Philomena, you are close, but I don't know why you added the y plus ln c. That's where you went wrong. So ln y plus x plus c. I can be able to give you another one. We continue. Number 5. X dy is equals to y dx. That one there. Try that one. Try that one. Give me an answer for that one. Guys and ladies are getting it now. So the first one, number 5. I'll start with number 5. So number 5, we said what? We cannot be able to integrate like this. The problem is what? The x is on the side of the dy, and the y is the side of dx. So I need to bring this x this side. I'll show you with an arrow. And then I need to bring this y this other side, on the side of dy, with the arrow like that. So number 5, if we do like that, that amount of dividing, number 5, we should be able to get what? Dy all over y is equals to what? Dx all over x. And now you can be able now to integrate both sides. I had shown you before, when you integrate dy over y, when because y is on the denominator, you get what? ln y. And then this one will get ln x. And now I want to introduce something else. I'll call my constant ln c, and I'll show you why. I will call my constant ln c. When you have ln, then you can still call your constant ln c. This is the reason why we call like that, because I can be able to simplify this one further using laws of logarithms. There's a law of logarithm you learned. Law of logs. Today you're learning a lot of things. Law of logarithms. When you have ln a plus ln b, this one is the same as ln a b. When you are adding two logs, it is possible to do what? To multiply them. Combine them and you multiply them. So that's what I'll do, and you'll be able to see my final answer. So bear with me. I want to simplify that one using this law. So I have ln y is equals to ln x plus ln c. I want to use this one using this law of logarithm. So I'll have this one ln y the way it is. Then these two I'll be able to combine them as ln c. I'm able to multiply them because I'm adding. And because I have that, for these ones to be equal, I can easily be able to see that y is the same as what? X and c. I can be able to drop. I can be able to drop the ln. It is possible to drop the ln and have y is equals to xc, or y is equals to cx. And I'll show you why. This one will be very, very important for us when we come later on to the logistic equation. It will be able to assist us a bit. So when you have ln, you can be able to, sorry, when you have ln, just call your constant ln c, then you use law of logarithms. When you're adding, you multiply them together, then you can drop now the ln. I think this one is a better solution more than what we had before. So maybe I'll do another one. Bear with me for now. Number 6. I'll do number 6 now. xy. I'll do number 6. I'll do number 6. So people are giving me for number 6. Okay. Let me see number 6. We had xy dy dx is equals to 1. So again, I have a problem here because I have x and y. So what I need to do is to take these words, is to take these. First of all, I'll cross multiply. So cross multiply is what I'll get. I do step by step. I'll get xy dy is equals, the dx has to come up. The dx has to come up. But now I still have another problem. I need to bring that x on the side of what? Dx. So this x here has to come all the way this side. Has to come that side. So what shall we get now? We shall get y dy is equals to dx all over x. Now it is possible now to integrate. When you integrate y, you get y squared all over 2. Integrate 1 over x, you get ln x plus c. I've called my constant C because there's no ln. Ln on the side of y there's no ln, so there's no need of calling my constant ln C. You call it ln C when you have ln on the y and ln on the x. Ln on the x. Very important. So final example. Number 7. You can try that. You can try that. I'm giving you number 7. You can try that. But I just do it. Let me just do it for the sake of time. So the recording is not that long. So I cross multiply. This one will come that side. So I'll have dy is equals to 2x squared plus 1. Then you must put the bracket. They are very important. Then I can be able to integrate both sides now. When you integrate both sides, when you integrate dy, you get what? You get y. When you integrate this one, you'll get 2x. 2 plus 1, you add 1 to the power, divided by the new power. Then when you integrate this one, we said this one, 1, when you integrate 1, you'll always get x. That's what we said, plus c. When you simplify this one, you'll get what? Y is equals to 2 over 3, x to the power 3, plus x plus c. So when you integrate 1, you'll always get what? X. When you integrate 1, you'll always get when you integrate 1, you'll always get x. That's what we have said. So the same procedure will apply. So now I'm on the last thing. The last thing quickly. People can be coming up with questions to ask. The last thing very important. We do how to make y the subject of the formula. Y the subject. For example, when you have ln, so number 1, ln y is equals to 2. Ln y, yes, you can say ln y is equals to 2. So how can you be able to, when you have ln and I want y, I don't want ln, how can I be able to make ln the subject of the formula? That's the question I'm proposing, how to make y the subject of the formula. What about dx? Try that. Kikotitian, kindly ask your question. What about dx? No, we had said about the dx, so integrating in terms of x. The dx, okay, let me go back to the example. This one, people who came, they were in class. This one is telling us we are integrating in terms of what? X. So you integrate this one on its own, and again you integrate this one on its own. So remember, when you multiply, when you open up the bracket here, let me give you what you shall be able to have when you multiply, when you open up the brackets, maybe for you to be able to see it. You have, you're integrating, okay, that's a wrong pen. So we were integrating 2x squared plus 1 dx. I jumped a step. So when you open this one, you'll get what? 2x squared dx plus the integration of 1 dx. We said we can be able to distribute the what? The integration. So you can be able to see here, it means that I'm integrating this function in terms of what? X. I'm integrating one in terms of x. The dx signifies. This one you'll get 2 over 3, x to power 3. When you integrate one, you'll get what? X plus c. So that is what it means. When you open up the brackets, this is what we should be able to get. And you distribute the integration. So that's what it means. We are integrating each term. The dx signifies you're integrating in terms of what? Yes. Okay, sawa. So I was how to make this one. Number one, let me go back quickly. Ln y is equals to 2. How can I be able to make y the subject of the formula? There is a relationship between ln and exponential. So relationship, very important, because this one I shall be able to use it, between ln and exponential. So check this one out, check this one out. Exponential ln y is the same as y. I wish you had a calc. I wish I was in class with you. I could have demonstrated this one. When I introduce exponential on ln, what does exponential do? You remain with only the function y. You only remain with the function y. When you have exponential ln y, you remain with what? Y. Can someone give me this one? This is the relationship. Can someone try this one? Number one, exponential ln x. What will be the answer? Exponential ln 3. What will be the answer? Someone give me the answer for the first one, exponential ln x, if you can be able to see that one. Exponential ln x, that is the relationship ln and the exponential share. So exponential ln y, you get y. You just the exponential removes the ln. It removes the ln and you remain with the function. Exponential ln x, someone to try? Exponential ln x. Exponential ln x, no one wants to try. So what exponential will do, it shall remove the what? The ln, it will make the ln disappear, and even the ln will no longer be there. So we shall end up with only x. Exponential ln 3. Exponential ln 3. Exponential ln 3. So people are getting it now. It's a very simple relationship. So you get it as 3. Only that. That is what it happens. When you introduce the exponential, you remain with only the what? The function or the constant. So let's go back to what we had. We wanted to make y the subject of the formula here. So if I want to make y the subject of the formula, I'll introduce exponential both sides. Exponential both sides. Yes, you introduce both sides to make the equation remain the way it was. So the first one, when I introduce the exponential on my left hand side, I'll have e ln y, and here I'll have e ln 2. So finally, my answer will be what? This side I'll remain with only y is equals to e 2. And that one will be the final answer. Remember, this other one, there's no ln on the right hand side, so it will remain just as exponential 2. So when you have ln and the exponential, I've said you remain with the function or the constant. So here I'm remaining with the function. So someone to try this one now. Number 2. Someone to make here y the subject. I want you to make y the subject of the formula. What will you get? If you get that one, then we are done. So give me the value of y. Value of y. If you get that one, then today I am happy. I'll be happy. But make y the subject of the formula then. Make y the subject of the formula. The recording, at least a person who was following. Introduce exponential both sides. Exponential both sides. So if I introduce exponential both sides, I'll have e ln y is equals to ex. Now we said something about when you have exponential ln y, you remain with y. These are the side you cannot be able to do it. You cannot be able to simplify. So you end up with that. We'll end up with that. Final one. Number 3. Ln y is equals to x plus c. Final one. Ya mwisho kabisa. The final one there. Give me that one. Resume the recording. So you have said introduce e. So I'll have e ln y is equals to e x plus c. Now on the left hand side I can simplify. I'll get y is equals to exponential x plus c. But now I wanted to go a bit further. I wanted just to go a bit further and tell you that I can be able to use a law of indices here to be able to bring the c down. So this one can easily be given a check this one out, exponential x, exponential c. It's not addition but multiplication. You multiply. When you have addition on indices, they are of the same base, the e and the e, so you can be able to separate them by multiplying. Now this one I can call this one another constant now. Yeah, I don't want exponential c. I can call it another constant. This one I can call it a constant, another constant. Let's say d. So here I'll have y is equals to d exponential x. Instead of having that, I'll have a better constant. I'll have d. So in some books you'll find something like that. You'll find y is equals to d exponential. Why? Because I've used a lot of indices. When you have plus, you can be able to separate them. Then exponential is still a constant. So I can easily be able to call that one d, or if you love your name so much, if your name is Emmanuel, you can call it E. If your name is Kazungu, you can call it K. It doesn't matter. If your name is Obama, you can call it O. So you can be able to have all those, but we don't recommend O. O can look like a zero. So you can easily be able to call that one D. So I hope that is a bit clear. I've used at least a lot of it. So I'll have to give a final one, and you give me the final version. The final version. The final version of this one. Number we are at now. I'm not sure if it is number 4. So and then for sure this one now we shall be able to call it a day. I think I've been. Is opening my pen. ln ln y, this one is number 5. Ln y is equals to now x 2x plus 3. No, because that one I'll not be able to use next week. Let me give you a better one. You will not be able to assist me. I'm going to use next week. X 2x squared plus c. Give me the final one and then you call it a day. That one, x squared plus c. Introduce the exponential both sides. You get exponential ln y is equals to exponential x squared plus c. Then y is equals to exponential x exponential c. Then introduce a constant d, and you are done. So I'm waiting now for questions now that may arise. You know,